Hey everybody, this is Mr. Walsh, and today we're going to be talking about atomic structure, which we know something about. Okay, it's hard to have gotten this far in chemistry and not known something about protons, neutrons, and electrons. And we're going to talk about Nuclide symbols, which is chemists' way of symbolizing elements on the periodic table so that we know how many protons, neutrons, and electrons there are. Okay, so this is a very large atom. You can see in the nucleus it has all these protons and neutrons. That's where the nucleus is. And you can see around the outside, the electrons form this cloud. So remember that it was Schrödinger, depending on how you pronounce this, I think there's an umlaut over the O, who developed the electron cloud model from the data and the math and did all sorts of great things. Okay, and so there's a nucleus in the middle, and then there's a cloud of electrons around the outside. Okay, so let's summarize what we should know or what we need to know about protons, neutrons, and electrons. So we have the three subatomic particles. So subatomic. Sub means smaller than the atom. Okay, so these are the three parts that make up any atom. Okay, and they're like the Legos. You put these Legos together, and now you have different elements that you can make up different atoms. Okay, and so so what you can do is you can pause this if you need to write this down. You're going to need to know this, so it's important that you get this written down in your notebook. Okay, so this is the symbol. A proton begins with P. That's a lowercase p in case it's not obvious, with a superscript, or like where the power goes, with a plus. Neutron is lowercase n because of neutron, with a 0, and then an E is a lowercase e with a negative up here. Okay, and this is where they're found. Okay, that's what we know. Okay, again, Schrödinger with the electron cloud, Bohr with the orbits that they're found in, but the cloud here is the most recent model, and then the proton, neutron, and the nucleus, and then the mass. So a proton and a neutron have the same mass, and an electron has a mass of 0. The charge of a proton is 1 plus, as compared to an electron whose charge is 1 minus, and a neutron is neutral and has 0 charge. Okay, so this is what we're going to use to make sure we can figure out nuclide symbols. Okay, so a nuclide symbol is a symbol that is used for an element or an atom of an element, where we can determine the number of protons, neutrons, and electrons there. And so what we have is, on the periodic table, you know that we have a symbol. There's no symbol X, so this is just any symbol. And then there'll be numbers in the corner. There's the atomic number, the mass number, and then the charge. And then down here, you already know this. This is the number of atoms in a molecule. So if we have something like H2O, the 2 goes in the lower right-hand corner, and that's how many atoms of that there are in a molecule of whatever it is that we're talking about. Okay? So we're going to talk about atomic number, mass number, and charge. So here's the thing. The number of protons is the same as the atomic number. So if you want to know how many protons is an atom, you're just going to use the atomic number. And just so you know, the number of protons is what defines the element. Okay? So I have a piece of a periodic table over here. And so if you are looking at this piece of a periodic table and you want to look here, this is hydrogen. Hydrogen's atomic number is 1. So that means that this has 1 proton. Okay. Now, we could also go backwards. What element has 1 proton? It's hydrogen. So when we figure out the atomic number, we also know what element it is, and we know how many protons it is. So there's a lot of information just by the atomic number. And the periodic table, like Moseley figured out, Henry Moseley, is organized by number of protons, or the atomic number. So that's exciting. Some practice. If we're going to have silver, we want to know what its atomic number is. To determine this, I'm going to pull out my periodic table and I'm going to look for Ag, silver. And when I do, I see it right here. And I'm going to look for the whole number. There's this number with a lot of decimals in it. But remember, the periodic table is arranged by atomic number. So 1, 2, 3, 4, all the way down. And so we get 41, 42, 43, 44, 46, 47. We get to Ag. So this has an atomic number of 47. And that's answers the question. Okay, we can do the same thing with argon. Okay, so we're going to come over here, argon. Okay, again, remember, it's the whole number. The periodic table is organized by number 1, 2, 3, 4, 5, 6, 7, all the way up to you get to Ar, argon. It's got a number, name on it, and then we're going to have atomic number 18. Okay, even though the question doesn't ask it, we also know that that's how many protons it has, right? And so now we can do it the other way. It says determine what element is number 35. So again, we break out our periodic table and we scan. Again, the periodic table is organized by atomic number, the whole number in the box, wherever it is. Different periodic tables have it different places. Sometimes it's here, sometimes it's here, sometimes it's here. Okay, so we count 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to 35. And that's going to be bromine. Okay. And then atomic number 92. I asked this because there's a funny thing that happens in the periodic table. So when we come down here, you'll see 56, 57, and then there's this star. Comes down here to what we call the lanthanide series, and it goes 58 through 71 is down here, and then it comes back to 72. Okay, and then when we go find 92, we have 87, 88, 89, 90, 91, 92. 92 is uranium. This is where I want to try to break up any confusion. The nuclide symbol is always has the atomic number here. Okay, the periodic table can put the atomic number anywhere because these are not nuclide symbols. These are just atomic symbols with numbers in them as a reference. Okay, so we want to know what is atomic number 53, and so we're going to look. We see atomic number 53 right here. That's iodine. Okay. Okay, and then atomic number 28, we can do the same thing. Okay, and you can see I'm just trying to reinforce what we already know. So take out your periodic table, look for atomic number 28. We go through, we find, again, a whole number. If you need to, just count the elements, 1, 2, 3, 4, 5. And as you count, you'll notice that the atomic number goes up. We come over here to nickel. Okay, N-I-C-K-E-L. Nickel is not spelled like pickle. Okay, that's one of my favorite things to point out to people. Okay, so now the mass number is the number of protons and neutrons. Okay, so when we come back to the original sheet, look, the only things that have mass are a proton and a neutron. And if we had something that had 2 protons and 3 neutrons, that, look, you can't even see it. If it has 2 protons and 3 neutrons, well, each of these weigh 1, so that's 1 and 1, and each of these weigh 1, so we would have 1, 2, 3, 4, 5. So all we have when we're trying to figure out the mass number is we have the number of protons plus the number of neutrons. Okay, so that gives us the mass number. And just as an aside, this is not the same as atomic mass. Okay, circle that, exit off. atomic mass is something different. We're going to learn about that very soon, but it's not the same. Okay, so in order to do this, we probably need to know the number of protons or the number of neutrons in order to figure out the mass number. Calcium is atomic number 20. 20 means calcium. Calcium means 20. You see that? 20, 20. Okay, and now it has a mass number of 42. So we want to know how many neutrons there are. Okay, well, we know how many protons there are. There are 20. And we know what its mass number is 42. So the number of protons plus some number is going to equal 42. Okay, so the number of neutrons in this case is 22. Okay, the other way that I like to do it is if you're given these two numbers, it's like going back to third grade and you're doing column math. Okay, you can find the number. Remember, this is the number of protons plus the number of neutrons. And this is the number of protons. So what you can do is you can just subtract these two. Look, protons plus neutrons minus protons gives you the number of neutrons, and that's going to equal 42 minus 20, and that's going to be 22. Okay, so there's a couple of different ways to look at that. Okay, again, practice. If you want to, you can pause the video and practice, and then you got the answer. Okay, so we're going to subtract these two. 31, this is 15. Okay, so the number of neutrons is equal to 15. We subtract the two. Okay, so now we want to know what the mass number is with 8 neutrons. So we know that it has 7 protons. So remember, mass number is protons plus neutrons. Okay, so it's protons plus neutrons. It's 7 plus the number of neutrons is 8. So the mass number is 15. Okay, and if I break out my periodic table, you'll see that that's not the number reported on the periodic table. Okay, that's a different number. So the mass number here is equal to 15, and we would put that number in that corner. Okay, so 127 neutrons. This is mercury. So now the mass number is 80 plus 127, and that's going to equal 207. So we're going to put 207 up in this corner, and that's the mass number. Okay, the last one that we're going to talk about. We're not really going to talk about the number in this corner yet. That's going to be a different whole unit. So the charge is a comparison of the number of protons and electrons. So look, this is just the number of protons. This is addition, and this one is compare. Okay, so every corner you have different things to do. Okay, and so the example that I want to show you is, what if sodium has a +1? Okay, so here's what we know. We know that sodium has 11 protons from the periodic table. So what I'm going to do is I'm going to do protons, and I'm going to do protons 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 protons. Okay, and these are all positively charged protons. So this is what I mean by compare. So for this to have a +1 charge, that means there needs to be one leftover positively charged proton, and all the other electrons have to cancel out, or all the other protons have to cancel out. We cancel them out with electrons, because if we go back to our chart, you will see that protons and electrons have the same charge but opposite. So if we have one proton and one electron, they cancel each other out to give you a charge of 0. Okay, again, and so if you have 2 protons or 3 protons and only 2 electrons, look, 1 cancels, 2 cancels, but you have one proton left over, so this charge would be 1+. Or if you had a case where you had maybe 4 protons and then maybe 6 electrons, look, these 4 cancel out, leaving a 2- charge. So if we are trying to get a 1 plus charge, we need to have this left over, and we need to cancel out all these. So I'm just going to write here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So to get to a 1 plus charge, we had to have 10 electrons. Okay. Lastly, I will say in chemistry, we always put the sign of the charge after the number. So if we have we don't write -3, we write 3 minus. Okay. Or if we have we don't write 2 plus, we write, look, we don't write +2, we write 2 plus. Okay, so we always write the sign of the charge afterwards. So oxygen, how many electrons does oxygen have? Well, the charge is 2 minus, and we know we have 8 protons. This number is 8. We know that oxygen has 8 from the periodic table, and that number isn't going to change. So look, protons, we will write 1, 2, 3, 4, 5, 6, 7, 8. We have 8 protons. Okay, but we need 2 more electrons. So electrons, so that's going to be 1, 2, 3, 4, 5, 6, 7, 8. But now we need 2 more electrons to make everything work out. Okay, so look. So how many electrons? 8 and another 2, so that's 10 electrons to make that work itself out. Okay, vanadium is a 3 plus. So vanadium, if we look, vanadium has 23 protons. So let's see what we got. Protons. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 20, 21, 22, 23. So there's 23 protons. And we want to have 3 of these left over, 3 protons left over. So now we can see that in order to cancel out, for this to cancel out, to leave 3 positives, we're going to get rid of these protons, not get rid of them, but we're going to cancel their charge with 20 electrons. Okay, and all these cancel out, leaving a 3 plus. So this is going to be 20 electrons. And again, if you want to do this, you can pause the video and try them yourself. Okay, so now we have aluminum that has 10 electrons, and we know, again, from the periodic table that aluminum's number of protons, or atomic number, is 13. So to get space, let's see here, protons, we're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And now with electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And look, we have 3 protons left over. So this is going to be a 3 plus charge. Sometimes you can do this without writing it out. I mean, you know, as soon as you see the pattern, that's what works. So like, okay, the comparison here, we're comparing 15. So again, we have 15 protons here, right? So number of protons is 15. The number of electrons is 18. So what is there more of? There's more electrons, so it's going to be a negative charge. And how many more electrons are there? 3. So it's going to be 3 minus. Okay, so we have some sample problems here, right? So you have these nuclide symbols, okay? So from this, we can tell how many, here I'll do protons, neutrons, electrons, and then it says give it symbol. So we'll do this symbol here, okay? So the number of protons is straightforward here. And again, you can pause this if you want to. So this takes all the information that we have learned and it combines it into one problem. So number of protons, 23. That's pretty straightforward. Now the number of neutrons, we subtract. 48 minus 23 is 25. So that's going to be 25. And then in order to get the charge, we have to compare. We have 23 protons, and we have a 2 plus charge, so that means we have 2 more protons than we have electrons, so that's 21 electrons. In its symbol, we have to look at the periodic table. We're going to go to 23, and 23 is vanadium, so its symbol is V. Okay. Okay, so then we're going to go down this way now. So the number of protons for this one is 38. We subtract. That gives us 50 neutrons, because 88 minus 38 is this. And now we have a neutral atom. When it's 0, that means the number of protons, number of protons is equal to the number of neutrons, because they cancel each other out, right? So if you had 2 protons and 2 neutrons, they would cancel each other out to give you a neutral atom. So this is 0, so that means the number of protons is equal to the number of electrons, so that's 38. And now we go to the periodic table and look for element number 38. Okay, kind of start here and see, so, okay, then like strontium, SR. Okay. Now the last thing that we can do is we can do what I call a chart problem. Okay, and so a chart problem is finding the number protons, neutrons, electrons, atomic number, mass number, charge. Okay, and then we can figure out its nuclide symbol if it's blank, or given a nuclide symbol, we can do this. So, okay, so here's what I'm going to do. I'm going to let you pause. You can fill this out. Okay, so now we're going to figure out the answers. Okay, so for sodium, in order to figure out the number of protons, we go here, Na, it's atomic number 11, so we're going to go 11. Now, how many electrons? When there's no charge indicated here, we assume that it's 0. So to assume that it's 0, that means that that's 11 electrons. Okay, and now we can do 11, and there's 23 neutrons. Remember, these two add up, so this is 34. Okay, atomic number 11, mass number 34, charge 0. Okay, so now let's do this. Now we can do all of this. We can do this, this, and this, and then we can write our symbol. Okay, so number of protons, the mass number is 50. So remember, 23 plus something gives us 50, so that's 27. And we're going to compare. So there's 3 more protons than there are electrons, so this is going to be 20. And the atomic number is the same as the number of protons, so that's 23. So now we go back. Look, this is vanadium again. We've done vanadium twice. Now this is the 3rd time in this slideshow. Okay, the number down here is the atomic number. And then the mass number goes here, and then the charge goes up here. Okay, so now we can do the same thing here. Okay, to determine the charge, let's see. Sorry, the charge is already determined, so this is 2 minus. That means there's 2 more electrons. The electrons are winning out by 2, so that's going to be 10 electrons. The atomic number is the same as this. The mass number is these 2 added up, so that's 17. And so now we can do this. This is oxygen. It's 8. Number of mass number is 17, and the charge is -2. Okay, so now again, if we don't have a number here, we assume the charge is 0. And we know this is the atomic number 27, and we know this is the mass number 60. Okay, so now from this we can come back up here, and now we will have 27 protons. Let's see. Neutrons is 27 plus something equals 60, so that's 30, or 60 you can subtract, and you still get 33 here. Then the number of electrons, this is neutral, so because that means these two numbers are the same. So that's 27. Number of protons equals the number of neutrons. Okay, so that's a long thing to talk about the number of protons, figure out nuclide symbols, not nucleotide symbols, and determine number of protons, neutrons, electrons in an atom, and all the things that are going on. I think we're done with long videos at this point, so everybody have a great day.